So what is VAR? VAR is value at risk, which is a statistical measure that estimates the potential losses in value of an asset or portfolio. So to explain this, I am taking the hypothetical example. For example, I have a portfolio which comprises of 10 stocks, and the value of the portfolio, let us assume that it is 200. Okay. Now let us suppose that the 10 stocks which I have selected are equity stocks and the risky stocks. For example, I have selected the equity stocks from the small cap. Now, if I have the risky stocks, it has the volatility, market volatility, and there is a daily market volatility. Because of the daily market volatility, it is possible that my value of the portfolio can move up. And it is also possible that my value of the portfolio can move down. Now, how much the value will move up and how much the value will move down, it will depends upon the volatility. And volatility can also be related to the riskiness of my portfolio. And I have already in this example have taken that my portfolio comprises of risky stocks. Okay, so now when if my portfolio value will go up, for example, it can be on the next day, it can become 400 or it can become 300. So if it will go up, what will happen is that I will incur profit. And similarly, if my value of my portfolio will go down, for example, if it will go down to level of 100 or 80, then I will incur losses. Now, looking into the VAR, so VAR is a measure for risk management. So when we are talking about the risk management, so we are only looking into how much will be my probability of losses. Okay, so in this example, when we are talking about VAR, we will only analyze how much is my probability of losses. Okay. The second point, which is important point to note, is that why we are calculating the VAR. Now, if the bank can able to estimate the probability of losses in the future, the bank can better able to pre-plan, and bank can better able to allocate the capital. I will say that the adequate capital bank can able to allocate, which will help the bank to survive in a crisis scenario when it will have losses. So this is why the bank calculate the VAR. Okay. So I have explained just an overview of VAR and why we are calculating the VAR. Now I am extending this example to analyze how we are calculating the VAR in more detail. Now you can look into this histogram. This histogram, based just from this example, based on the model I have applied, I'm able to calculate what will be my future value, daily value of my portfolio. And it is following the normal distribution curve. So this is the normal distribution curve. And you all have some understanding of normal distribution. So what this normal distribution, when how you can observe this normal distribution, there are towers in this normal distribution which you can able to see, and you can able to see that the height of the tower is going down when you move right, and height of the tower will go down when you move left. So the height of the tower represent the frequency or a probability of loss. For example, if I have a loss which is 0, at that point my probability is highest. Similarly, if I move right, I will have a profit and my probability of profit is decreasing. Similarly, when we are looking into this normal curve on on left side, sorry, so you can observe that my probability of losses is decreasing. Now you are able to see that there is a point, there is a line which divides this distribution in two colors, which is in blue and which is in amber. So this line is called the confidence level of the distribution. So for this distribution, the confidence level, which is 95%, which is at this point, which is dividing this histogram into two parts. So it means that my right side of the distribution, which is in blue color, comprise of 95% of the total distribution, and my left side comprise of my 5% of the total distribution. Okay. Now, when we calculate the VAR, so for example, at 95 percentile or at a 95 confidence level, my VAR value is 100. It means that, for example, if my value of the portfolio is 200, I am able to lose the 50% of value of my portfolio, and at 95% my value of the portfolio, my losses is 100. Okay. And when you look into the blue region, you can say that there is a 95%. I am confident that my losses will be less than 100 within the defined time horizon. For example, the defined time horizon for this distribution is daily. Now, when you look into the left side, which is the amber color, then you can say that there is a 5% chance that your losses will be greater than or equal to 100 within the defined time horizon. Now, if you read these two statements, these two statements have same meaning. Okay, but when you look into the blue color, which which is related to the second statement, when you are looking into the red color, which is related to the first statement, but both the statement have same meaning. So what I will advise is that read these statements multiple of time. Okay, so this will help you to build more understanding of the where concept. Now so when you look into this daily where or 95% where or where which is in bracket 5%, it is same thing. So it means that when I am writing this 95% where, it means that my where at a 95% confidence level. And when I'm writing this where in the bracket, if it is 5%, it means that my where at a 5% significance level. Okay, so the significance level is equal to 1 minus my confidence level. My confidence level in this example is 95%. So my significance level in this example is 5%. And what is the value of the portfolio at this level? 95%, where at a 95% confidence level, where, or a where at a 5% significance level, which is 100. Okay. Now, I will explain you there are two important parameters for where, which is confidence level and the holding period. So bank will decide the confidence level based on the risk appetite of the bank, or the how much is the risk taking ability of the bank. For example, if I am looking into the 90% confidence interval or a 95% confidence interval, the 90% confidence interval where will means that the bank has more ability to take risk. And when bank is taking 95% where for its calculation of where, then it means that bank is taking less risk. And you can look into this, the how the where will look based on the confidence interval we define. For example, if we have a confidence interval more towards the left side, it means that my where value will be more. And if I have a confidence interval which is more towards the right side, it means that my where value will be less. So I can say that where at a 90% will be always less than the where at a 95%. Okay. So this will, I mean, I'm just trying to explain the conceptual knowledge. This will help you to develop the conceptual knowledge of where. The second important parameter is the holding period. The holding period can be daily, weekly, or monthly. So holding period means that if I have a portfolio, if my holding period, for example, is monthly, or if the time frame of the holding period is more, there will be more risk to my portfolio. There will be a more chance of volatility in my portfolio. If there is more volatility in my portfolio, it means that there is more risk in my portfolio and my where will be more. So the point I want to make here is that the monthly where will be always more than the weekly where, and the weekly where will be always more than the daily where. Okay. Just a point to make here. What is the relationship between if the holding period will increase? So it is observed that if my mean value of the distribution of the portfolio is 0, it means that if I have a where which is daily where, okay, which is a daily where, if I want to calculate, for example, weekly or monthly where, it will be increased by this factor, which is root n. N means the number of days. For example, if I have a daily where, if I want to calculate the weekly where, then I have to multiply by the factor which is root 7. Okay. If I want to calculate the monthly where, then I have to multiply by the factor which is root 30 or root 31, whatever. Okay. Now, I also want to touch upon the limitation of where. So when we are looking into this where, so we are only focusing on this point. We are not looking into what will happen to the left side of this point. So I know that the probability of left side is very low, but still there is a probability of happening. The probability is low, but still there is a chance that it can happen. For example, if I have a loss which is more than this confidence interval, for example, if I have a loss at this level, then my VAR will not able to account that. So this is the limitation of VAR. So there is another measure which is called expected shortfall, which is which overcome this limitation of the VAR, which also looks into this region, which is the left side. I will explain you the expected shortfall in the next slide. So what is expected shortfall? Expected shortfall is a financial risk measure that estimate the average loss in a portfolio after a loss event exceeds a certain threshold. Now, looking into this histogram, so the expected shortfall, we are taking the average of all losses which is beyond the VAR threshold. So in this histogram, we are looking into the losses in this region which is beyond VAR. This region is also called the tail of this histogram. So in the tail of this histogram, we have losses which has very high severity, although the probability of the losses are very less. So what we are doing in the expected shortfall, we are accounting all the tail losses in calculating the metrics for expected shortfall. So we can also say that the expected shortfall is a more robust approach to do the risk management. Now, I'm just taking one example here to understand this. For example, I have used any model and I have calculated my scenarios for losses, and I have calculated total 100 scenario for my losses. Okay. Now I am looking into the worst three losses. My worst case three losses, for example, my third worst case loss has a value which is 4 million, and my second worst case loss has a value which is 3 million, which is for which has to be always more, which is 5 million, and my worst case loss is 6 million. Now in this example, I am looking into the expected shortfall which is at a 97% confidence interval. And at a 97% confidence interval, my VAR is, let's suppose, which is 2 million. Okay. Now to calculate the expected shortfall, we have to look into my losses beyond the VAR interval. And I have to take the average of all the losses. So the average of all the losses in this case is 5 million. Now, what you will observe here is when we are calculating the expected shortfall, we are looking into the more comprehensive picture of the potential losses. and the number we have evaluated, which is 5 million, which is higher than what we have evaluated in the where. So in the where, we are not accounting our all losses. So if we are using where as a risk measure, then I will say that the bank is taking more risk. So expected shortfall is a more robust approach for risk management. Now, the Basel 3.1, which is also called as the Basel 3 Endgame or a Basel 4, has provided the guidelines for the banks that it should use expected shortfall. So what it is saying is that the bank should replace the where and use the expected shortfall to better capture the extreme losses or to better capture the tail loss, and which is at the 97.5 confidence interval. So the bank will move from the traditional model, which is where, to the new model of risk management, which is expected shortfall.